Okay, now I want to do a couple of examples of U substitution in definite integrals. Um, there's a couple options, and I'll show you both options, and you can take the choice of which way you like to do it. So here's uh, something. This is not just an x to the 8th power, so there's a chain rule involved, so there's the antiderivative of a chain rule, so there's a U substitution involved here. I'm going to let U be the stuff inside, 3x minus 1. And so then du is 3 dx. So I'm going to throw a 3 in and take a 1/3 out. Um, one thing I didn't mention before, but I want to do it now, is that I can do this with a constant because I'm essentially multiplying by 1. I'm doing a 3 divided by 3 and using a property of integrals that allows me to pull a constant multiplier out in front. I cannot do this with like an x over x and pull a 1 over x out in front because I cannot pull functions across that integral sign, but I can pull multiple, multiplying by a constant through there. Okay. So now, what do I have? I've got 1/3 an integral, and I'm going to put a couple of question marks right here. No, I already did that one. I'm going to do this the other way now. So I'm going to do a u to the 8th power, and the 3x dx is the du. Okay. But now what I'm going to do is I'm going to change those limits of integration because I'm going to look at this and say, hey, if x is equal to 0, the lower limit here, if x is equal to 0, then this tells me what u is. Then u is equal to 3 times 0 minus 1, which is minus 1. So my lower limit now will become a minus 1. It used to be 0, and now it's a minus 1. Now with x equal to the upper limit of 1, I plug that in and find that u is equal to 3 times 1 minus 1, which is 3 minus 1, which is 2. So my upper limit now becomes 2. This integral now is completely transformed into u's. I was a little careful last time. I was careful by leaving this x equals and x equals because I had to remind myself these are not u values, those are x values. I got to get back to x's like I did here. Okay, but now everything is u's. This is u equals minus 1 to u equals 2. Right? We made that substitution based on this. We changed the limits based on the same substitution that was changing everything on the inside. Okay, so this now integrates to 1/3 u to the 9th over 9 evaluated between minus 1 and 2, which will be 1 over 27 times 2 to the 9th minus 1 over 27 times minus 1 to the 9th. Okay, and actually notice that we're really in the same place as where we were before, because when we plugged in, after we got back to x's and we plugged in, we did have, here's the 2 to the 9th, and here's the minus 1 to the 9th. We ended up doing exactly the same thing. And ending up with the same answer here. For some reason, this is doing weird things to me. It won't let me move and write at the same time. But okay, here we go. So yeah, this is still 512 over 27 minus -1 over 27 for a grand total of 513 over 27. So when you're doing a definite integral with U substitution, you have two options. You can either um, leave the limits alone and then uh, make sure your function gets back to looking like x's, then plug the x values in, or you have the option of converting everything, including the limits of integration. Um, all of this gets converted into u's, and then you don't have to come back to x's. You just plug those u values in. There are people who prefer one way or the other. I don't care which way you do it. I probably would do it the first way myself, but I'm getting more so that once in a while I do it here the second way. Let's try one more example. let's do the integral from 0 to 1 of x e to the minus x squared dx. I do this just because we haven't done an e as well. Um, Here's a u substitution where there's really parentheses right here. The function, the outside function is e raised to a power, and the stuff on the inside is that stuff in the power. So I'm going to let u equal minus x squared. So du is the derivative of that, minus 2x dx. I see an x dx. I'm missing the negative 2. So let's put it in there and then multiply by minus a half, right? The net result is I multiplied by 1. I multiplied by a minus a half, and I multiplied by a minus 2. That's the same thing as multiplying by 1, so I didn't change any values here. All right. If I'm going to change, let's change the limits as well. If x equals 0, then u equals negative 0 squared. 0 squared is 0, negative 0 is still 0. Likewise, if x equals 1, then u equals negative 1 squared. And remember, order of operations, you do the square first and then the multiplying. So this is 1 squared is 1, so that's minus 1. So this becomes, there's a minus a half, the integral, the 0 turned into a 0, the 1 turned into a minus 1, and this now is e to the u times du. The e to the u is right here, and then the minus 2x dx, all of that stuff is the du. And I can do that. Slow down. I can integrate e to the u du. That's just e to the u. So this is e to the u. Actually, there's a minus a half out in front. And evaluate that between 0 and minus 1. Another thing I want to show here is that this multiplying, I've been keeping that with the function, but you can just leave it out in front. It doesn't matter because there's a distributive property. And then you can just plug the minus 1 in, plug the 0 in, and subtract. You can put the minus a half in with each of those if you wanted, or you can leave it out in front. Either way works just fine. Okay. So anyway, e to the 0 is just 1. So anyway, minus a half, e to the minus 1, minus 1. Okay. There you go, definite integrals with u substitution.